Okay, well, yes, thank you very much. I'm Chad Nelson, a principal advisor at Infrastructure Canada, responsible for adaptation and resilience in our policy and results branch. And today we're going to flip the script a little bit with, I'll begin lovely having the privilege to welcome you to the 38th meeting of the Infrastructure and Buildings Working Group, held under the auspices of the National Adaptation Platform, and has been led by Natural Resources Canada. And I guess flipping the script in that, I'll walk through some of these sort of the technical information, and then I'll turn to Dan to kind of give an overview of our time, our meetings together. So first of all, please do keep yourselves muted. Please switch on your camera when you're making a comment or asking a question. Always helpful if people wish to identify their organization they're coming to when they speak up. Also would really encourage people to submit questions via the chat box at any time during the meeting. I should note the meeting is being recorded. We'd also welcome you to feel free to invite your colleagues to participate in the working group. We are seeking to maintain this as an open forum, really for exchanging on best practices across the country. Feel free to enter into the chat in regard to that. Any information, particularly on new or upcoming reports, resources, initiatives that are of interest to the group, upcoming meetings, conferences, workshops, those that could be of interest to any of our members, as well as some future meeting topics, suggestions to the IBWG. And you have Dan and myself and Anna Murphy from my team, who are go-to people to connect with in regard to sort of future activity of IBWG. So I'd also like to let you know we will distribute a follow-up email to the full group after the meeting, which could be helpful to those who may not have been able to attend today. And I would also like to take this opportunity to really share with you a renewed Infrastructure Canada webpage, which Anna Murphy will kindly toss into the chat. Just to say, as folks may know, we've often brought the National Research Council and the Standards Council of Canada to profile some of their work on emergent guidelines, standards, practices in regard to how do we advance climate resilience in infrastructure and buildings. The webpage that we've just updated provides fairly significant overview of some of the work that Infrastructure Canada has had the pleasure to fund and the privilege to continue working with the NRC and SEC on that work. So just to say, that's one of the first resources to illustrate how the chat can be useful for sharing resources. I think with that, Dan, I'm going to turn it over to you. I've made sure that my cat filter is off me for today. So over to Dan.
Thanks, Dad. That's a good memory from the early days of the pandemic, the cat filter. Thanks everyone for joining. It's really nice to see everyone here. We've got a really good turnout once again. I just wanted to point out further to what Chad said. During our last meeting in June, we had a really good discussion about the National Model Construction Codes and considerations for climate resilience in those codes, including the revamped governance process for construction codes in Canada, the change process, the updating process for 2025 and 2030. We had a really great discussion with some of the senior staff that are responsible for construction codes in Canada. That meeting was recorded, and we can share a link to that meeting if you happen to miss it. And we also have links for YouTube postings of previous meetings going back to, I believe, June 2021. So if that's something of interest, let us know, and we can share those. And I believe we can share those links in the follow-up email once the meeting's completed. And just apologies if I'm distracted. I'm admitting people as I'm talking here. One thing that I'm going to actually give everybody a bit of a heads up. I'm going to start a poll very shortly, and we're going to give ourselves just a couple of minutes to respond to a poll. And what we're trying to achieve with this poll is get a sense from this audience of priorities for topics, discussion topics for IBWG for the coming couple of months to next year. So if you remember, a few months back, we had a session where we received input from members of the IBWG about the purpose of the IBWG, outcomes, meeting topics, topics that should be a focus for future meetings, how to align IBWG activities with other ongoing initiatives in Canada. And we received some feedback about priorities for future meetings. And one piece of feedback was that we should focus on implementation in many respects. And we had a number of areas or sector areas or topics that were identified by participants as priorities for future discussion. So I'm going to launch a poll here. We'll give everybody about 1 minute or so to respond to the poll. It's a multiple choice poll. You should be able to select more than one response. And the idea here, as I said, is to get a sense from you of priorities for meeting topics in the future. And if there's any topic here that's of interest, we'd also welcome you in the chat or following the meeting to let Chad, Anna, or myself know of topics that you would be interested in. And even if you yourself would be interested in presenting, or people from your organization or from your agency would be interested in presenting, you're always welcome to bring those ideas to us. Often it's Chad, Anna, and I that are sort of looking to identify topics and presenters. We want to make sure that all members of the IBWG have an opportunity to suggest presenters and also present themselves when the opportunity arises. So I'm getting some feedback here. We've got 39 responses. Nice to see that actually a pretty solid, consistent response of all topics, all topics of interest. But I'm seeing some good feedback here. And some of the things we're thinking, I mean, these are topics that come up all the time. Topics like applying future climate data. I know this is like an ongoing a topic of interest in the adaptation community and in engineering and so on across the board. But what we might be able to do in this group is bring to a more public forum examples that you may not have seen before, more regional examples. And one example that we've come across recently is some work in Quebec where future IDF curves have been integrated into sewer design standards at BNQ that are sort of now more widely applied across the province. We may not have seen examples like that across Canada. So we'd be looking for examples like that, local examples that we can bring to light through the IBWG. So I think we've got just about everybody got 49 responses. I'll give you one more second. If you haven't responded yet, feel free to respond. Okay. I'm ending the poll and I will share results. So hopefully you can see the responses there. So we have quite a spread, lots of consistency in responses, but a few are sticking out here. Natural infrastructure's role in climate resilience, residential housing climate resilience, municipal resilience requirements, and a very close second, all other topics, and a few other topics as well. So I haven't had a chance to look in the chat, but if you do have other topics of interest, please do submit those in the chat. And we'll do our very best to represent all of these topics in the coming months. One other thing before we get started really quickly is that we have been working to collect contact information in areas of interest from our membership. And I believe Anna will post a link in the chat for a form that you can fill out that we would like to eventually publish and have available to IBWG members, but also the general community, to give people an indication of who is working in what area, the topics of interest. We think that this can be a useful resource for practitioners and researchers that are working in climate adaptation in buildings and infrastructure. And we will share the directory, and I suppose we would ask that people share information on the directory, responsibly. We're not looking to spam people with information, but we think this is an opportunity to share information about who is working in what areas across Canada. Okay, so now I'm going to turn it back to Chad for a quick introduction to our presenters today.
So we'll begin today with presentations by Eric and Thurston and Anna Murphy, who work in the Policy and Results branch, and we work together very much on resilience requirements, and they'll provide an overview of our work in Infrastructure Canada in this regard. And then we'll hear from Ron Mattiusi, who's here to talk about his experience in addressing wildfire impacts in British Columbia through a municipal lens. And following There will be a brief discussion period with our next round of presentations, where we'll focus on resilience in residential buildings, beginning with Zara Jandangian from the National Research Council to discuss work on managing overheating risk in residential buildings, and then to Stephanie Coleman from Natural Resources Canada, the LEAP program, to discuss, again, sort of resilience for Canadian homes. So I'll first just introduce Eric and Anna, if I can here. So Eric Thurston is a policy analyst in our team in Infrastructure Canada, like I said, and he's working towards crafting resilience requirements for new Infrastructure Canada funding programs across Canada, and addressing the National Adaptation Strategy commitment, where climate change impacts are factored into all new federal infrastructure funding programs starting in 2024. Prior to his work at INFC, Eric had worked at the Federal Emergency Management Agency and the U.S. Forest Service, supporting cultural and environmental legal compliance for a variety of disaster and non-disaster projects, as well as regional and national program policy directions. Anna is a junior policy analyst in our team, and prior to her work with us, she worked for environmental not-for-profit organizations and research groups in Nova Scotia, implementing nature-based solutions to reduce risk of climate hazards on both the community and the individual scale, and has led research studies with the World Wildlife Fund for Canada, exploring the role of municipalities in managing blue carbon ecosystems for climate adaptation. She also recently completed her Master's of Resource and Environmental Management from Dalhousie University. I learned so much from these two folks every day. It's great working with them, and I'm really pleased to have them lead this section of the meeting to discuss our work on resilience requirements. So we're going to turn it over to Anna and Eric, and I'll go on mute. Okay, great.
Perfect. All right. So I'm going to start us off today. Good afternoon, everyone. As Chad mentioned, Eric and I are working towards creating resilience requirements for Infrastructure Canada's new funding program. So the purpose of today's presentation is to introduce what that process looks like that we've been creating in its draft form, and hopefully hear some of your feedback during that discussion period. So we'll begin by looking at the key drivers of the resilience requirements process, kind of how we got here and why, and how the lessons learned from the climate lens, which many of you are likely familiar with, helped shape our current vision of what a scalable approach to risk assessment and risk reduction looks like, and in supporting building climate resilient communities in Canada. So next slide, please. And so the big key driver, the bread and butter of what we're working with, is the National Adaptation Strategy. So as Chad just recently mentioned, we're working to address, this is the resilience requirements process is the mechanism by which Infrastructure Canada is addressing the 2024 National Adaptation Strategy target, which is starting in 2024. Resilience to climate change impacts is factored into all new federal infrastructure funding programs. And so that's really kind of like our guiding force when we're working and creating this process. Next slide, please. So luckily, we're not working from scratch. I did mention the climate lens, and essentially the resilience requirements process builds off of those lessons learned from the climate lens, which were identified in a 2021 assessment completed by Stratos. So a few key items that were identified within that report include the need for a scalable approach to risk assessment and risk reduction measures that still maintains the scientific rigor and accuracy needed to support community and asset resilience, as well as this need for sector-specific guidance for applicants. So when we're considering sectors such as water, wastewater, buildings, and transit, they have their own specificities to take into account when they are implementing risk reduction measures into their planning and design phase. And so how can we better guide applicants during that process? As well as we want to continue to enrich communication with applicants. And so this was something that was found to be a real success of the climate lens, was how the plain language that was used in sort of the second iteration really increased applicants' understanding of climate resilience. So when we're thinking of building that capacity for applicants and across Canada for all Canadians. So we're looking to continue this path through coordination and partnership with our sort of sister team at Infrastructure Canada, the Climate Toolkits and Supports Office, in creating capacity supports for applicants. So that's one-pagers, FAQs, some recorded webinars, things like that. And this would be hosted on the Climate Toolkits platform, but Eric will expand on that a little bit more later on in the presentation. Next slide, please. And so with knowing our NAS target and knowing what was done well and what needed a bit of improvement with the climate lens, we have 3 key features that really guide the creation of the resilience requirements process moving forward. And it's that scalable risk assessment that will help us identify help applicants identify current and future hazard risks. A risk assessment that aligns and is based on internationally recognized risk assessment processes. So we're really looking to ISO 14091 and PIBC in this case. And ultimately, we want this to result in identifying suitable risk reduction measures that are either recommended or required to reduce climate hazard impacts to the project. And so these risk reduction measures are supported by the development and the making available of codes, standards, and guidelines from the National Research Council and Standards and Codes Canada, which is founded on the latest available climate data. So really moving forward in this space. Next slide, please. And so this slide provides a brief overview of the details of our risk assessment, and then I'll give you a bit more context before I'll hand it over to Eric to see what these key features really look like in practice in the workbook that we've created in our draft form. So first, we're using project cost to be the determinant of our scalable approach to determine which stream we want applicants to sort of go down. And with the intention that the smaller projects will undergo a light approach and larger projects being directed to a comprehensive approach. The cost threshold that we're using here is $10 million. So projects above $10 million go to the comprehensive stream, below to the light approach, And this really allows small and large projects to approach resilience in a way that reflects federal investment. This cost threshold, you'll recognize it's subject to change, the asterisk there, and likely will be tailored to different Infrastructure Canada programs to best represent what their large and small projects look like, because obviously this will look different depending on the program. Other determining factors to direct applicants to either approach were explored outside of just, this cost threshold, including the level of risk and the criticality of the asset. However, in practice, we found that those criteria kind of resulted in a bit of redundancy. We're asking them to do a risk assessment before their risk assessment, and there wasn't a lot of value added in the end. So we're looking at cost, and there's a lot of sort of alignment when we're using this approach as well. And so both approaches require the applicant to complete a risk assessment, and it results in a pre-populated list of those codes, standards, and guidelines based on the level of risk of the climate hazard. So the light approach risk assessment is simplified, as you see on the left side there. It looks at the project asset as a whole, and then the likelihood of the top climate hazards and their consequences. And the resulting risk level from this assessment is streamlined risk index. So it is low, medium, or low, moderate, or high. Whereas the comprehensive approach for a risk assessment is a fulsome review of the hazards for the asset components and a review of hazard likelihood, exposure, and asset vulnerabilities. And this approach really is aligned and based in ISO 14091. And because the information here is collected a bit more detailed, the list of applicable code standards, guidelines, these risk reduction measures that we're helping provide for applicants, they're more tailored to the project itself. So that gives you a little bit of an overview. And now I'll hand it over to Eric to sort of introduce the workbook that we will have available for applicants and to walk through the process.
Sure. Thank you very much, Anna. And I'll say currently we are working through these two different approaches, the scalable, light, and comprehensive approach within an Excel document. It's kind of the easiest, most approachable way for us to currently do it. How it will look, this is very draft as we're continuing, still developing. So presenting to yourselves here is extraordinarily useful, and appreciate any comments we do receive, because this is still something in development. And for example, this workbook itself as well is in development because we're currently working through Excel, but we're hoping that we can turn this more into a web-based online supported system that's attached to a database in the background so that we can pull great reports from it and really have that kind of annual understanding of what's happening and how our applicants are approaching risk and looking at those reduction measures. But for this as a kind of a view of what our light approach looks like within this document, as you can see, there's project location and asset type right at the top. We're asking some of that basic information. There is going to be additional information that we're trying not to be redundant with that's already going to be coming in through project applications. So we got to ensure that we're, aligned with that, what information does come in, but there will be a number of project details that come along with this that aren't necessarily shown here. But as you can see, the first part is looking at those top hazard risks. This is subject to change. We've been told many times needs to grow. We need to split out the flood piece in order to really be more effective in the codes and standards, especially the standards that are available that we can require or recommend. But the idea behind it is that we're looking at creating this risk formula through a simplified likelihood and consequence by asking questions about past incidents as well as future likelihood. And by future likelihood, specifically, we're looking at what at that end of lifespan for your asset, what does that future likelihood look like? We're still talking about which model and which ensemble we're using, what scenario for that. But really, it would you'd create the applicant would then put in low, moderate, or high based on that hazard, and then that would auto-populate a score for them. And then they would also tell us, like, where was this information coming from? What is the rationale, the justification for that? Part 2 would provide information on the consequences. As for those who've read 14091, it's value-based. We recognize, there's uncertainty that comes with this. There is a lot of self-identification. There's stakeholder engagement needed in this part. But overall, at a high level, we're asking them to look at and understand what is the potential impacts of that hazard and define it based on that low, moderate, high risk index that you can see there at the bottom. We will be looking across and doing a scan about how people are identifying, that future risk and being able to kind of turn it in. Might be one of the first questions you're thinking now, turn that into a low, moderate, high definition. What does that mean if we're talking, 30-degree days over, days over 30 degrees for extreme heat? But we're looking at that. We're looking to see how others have really approached that to be able to support applicants in a very kind of, I don't want to say basic, but a more simplified approach to help support all projects coming through. And so they can have an automatic populated score come through. That would then result in a final risk index along that 3x3 risk index model of low, moderate, or high. Following this, we do have, and this, I recognize that this slide is very dense and it's hard to read. You might have to zoom in, but I'll just talk to it. But basically, as you can see, it's more comprehensive. There's a lot more boxes here. And to say these boxes are aligned with 14091, we're looking at what is the climate hazard. Similarly, we're also asking information about exposure and what the setting is, what kind of community could be impacted by the loss of service or the loss of this asset. Also looking more at a component level, which is what is the component sensitivity to those hazards, as well as what is the adaptive capacity that already exists for that asset to factor that in to that overall risk index. All the gray boxes are auto-populated, and it's going to end up in a 5x5 risk index model, which most of you are probably more familiar with. A lot more of the reports that I see come out are all more focused on that 5x5, very low to very high index model. And then based on that, again, it would support understanding, okay, what are the sensitivities there? What's the full overall risk index as it's been auto-populated, which will lead to an auto-generated list of codes, standards, and guidelines that are going to be either recommended or required for applicants as they come in, and this is all going to be happening at the planning and design phase of the project. And so that auto-populated list is something that we're working on. We have been supported by NRC and SEC. We're also really looking to determine, which standards are most reflective and most supporting of climate resilient options within that, and really help kind of better identify how that investment, that Infrastructure Canada investment, can be supported through those existing codes, standards, and guidelines that would be pre-populated based on that information. Now, as I said, this is also something that you're probably thinking, this is all growing, it's changing there's new standards coming out all the time. And honestly, Infrastructure Canada is doing a lot in this space as well. There's a lot of work, including new standards on flood, wildfire, permafrost, new tools, guidelines, and research reports are coming out all the time. There's additional information going to be out in the new 2025 codes and even 2030 codes, and as well as changes being made to the National Master Specification. So the key thing here is that we want to make sure that this is also evergreen, and that we're continuously using the work that's already going on with NRC, with SEC, and all the great work by all the other people that are supporting other organizations, standard organizations like CSA, that this is an evergreen process, and that we can continue to help support in whatever way possible to ensure that those projects that are coming into us are using the best information, climate resilient information as they can, either, like I said, either requiring it straight out, or a lot of times also just recommending and building awareness for that applicant and that proponent. Now, one of the other things is capacity support. How are we going, now that we have this, if we have this new tool, when we have this new tool that comes out, how are we going to be helping people in decoding this and how it works and what we're looking for when they fill out this information? And we're going to be standing up quite a lot of support tools in the future as we work through this ourselves. One of those tools is we're going to be creating guidelines and sector-specific annexes to help support this. We're also going to be conducting a number of outreach sessions and engagement sessions. We're starting to do that now, and we're also going to be doing that in the future, as well as building a more comprehensive training program for that we'll have invitations going out for. Another piece is going to be, there's the Climate Toolkit and Support Services platform that is going to be forwarded in the future, and that's going to have help desk coordination. It'll have support from a roster of practitioners that will be available to help support applicants. It'll have a number of online resources, and there'll be workshops and guides. And I know there are a number of resources already that are out there that do factor into this, and our Climate Toolkit and Support Services group is working together with them and having coordination meetings with them and really understanding where are the gaps and where can we really help move things forward, especially for applicants that are coming and seeking Infrastructure Canada funding, but also everyone as a whole. So with that, just some short takeaways that we're building these new resilience requirements off of those lessons learned. There's a number of other lessons learned that we do have, but we're looking at all those and saying, okay, what have people said really worked? What didn't work? Let's look at Climate Lens 1 and 1.0 and 2.0, and how can we better provide support to applicants in building awareness and creating more climate resilient infrastructure, and at the same time ensuring that federal investment. We're doing it in one of those ways is through a more scalable process. It's not a one-size-fits-all process, and so we're looking at how could we be scalable, and we're doing that through these different approaches from light and comprehensive. We're also, and one of the things we heard back a lot is align with international standards, align with that new 14090 family that's coming out, including 14091 and those definitions, and looking at exposure, building in community equity, building in those kind of aspects to make sure that we're really looking at risk in that totality, in that fulsome way that's outlined in 14091, and that as as a framework, not necessarily methodology, as we're being agnostic on methodology, but as a framework for defining that. We will say, and I haven't said this yet, a lot of questions have come up in other presentations, will we require professional attestation? For the light approach, right now as it stands, we're going to be looking at an agency's official sign off on those projects. But for the comprehensive approach, we will be seeking that professional attestation. And then the last thing, as I just mentioned, capacity support. We're working closely with the Climate Toolkits and Solutions Office. We're also speaking with CCCS. We're also speaking with public safety on work they're doing in flood mapping. We're working with a number of groups, but we're also trying to see, okay, what is the best way that as we continue to develop this process, how can we really make sure that we're reaching out to applicants, whether they're low capacity applicants, high capacity applicants, or new applicants, or ones that have already been through this process and see those changes, to really be able to hone in our message to all of those and be able to engage in a way that helps them understand what we're looking for and makes it easy and simple for them to go through this process and be able to finalize that for their application. So that's our whole presentation. I just want to say thank you very much for listening to Anna and I. I will also leave with this one other final tidbit, which is, as I said, it's draft. We're still working on it. We're still developing this process. And if there's anybody out there now who would like to learn more, have a more direct conversation about it, and talk more deeply about some of these aspects, or what you think, how it might impact the community you represent, or how it might impact, being a practitioner in this, or whichever, we are very happy to speak with you. Please send Anna and I an email, and we'd be very much looking forward to having those conversations. So with that, I'll say thank you, and that's all.
Thank you. Thanks very much, Eric and Anna. I really appreciate that presentation. I would say that the chat discussion is rich and alive on this call. If people haven't turned that over, I'm glad to see some hands coming up for questions, because indeed we're going to change the agenda just a little bit. Dan and I just conferred behind the scenes and have some brief discussion now for about 5 minutes. We had planned to have about 10 minutes after also our second main presentation. So Ron, we will come to you in just 5 minutes or so. And with that, I'm about to open to 5 minutes of discussion here. I did want to note, but as I close the meeting, I have a little surprise fun announcement for IBWG I'll make in my concluding remarks to hold a little suspense. So with that, Elise, I think I saw your hand up first.
Hi, Chad.
Hi, nice to see you.
Good to see you too. This is great work. I love, obviously we've spent a lot of time talking climate lens, and so to see this evolution and have the NAS requirements come in, I'm like 2 thumbs up. Super stoked. One thing that came up, I volunteer with the Climate Change Working Group for the National Bridge Code with CSA, and a fulsome discussion that we've been having is the fact that the code is going to reference RCP6, and by the time the code is released in 2025, obviously working through a 5-year code cycle, RCPs are likely going to be obsolete, and we're going to be moving towards a different terminology, whether that be SSPs, whether that be a temperature increase globally, and what that means, and where the equivalencies are. In terms, one thing that I picked up immediately was the requirement to have the best available climate data and information. And so as that's changing, is that going to then require a higher or a different standard than what would be in the code? Or is it these are just some of the little complications that come up. Obviously, we want to be using the best available information as it's an evolving science. And so just wanted to bring that up for something to consider.
It's definitely interesting to work in a dynamic policy environment. I'm going to turn to Eric, my colleague. And
I was just going to mention briefly that, yes, we've been having those conversations as well. We've been talking about the scenarios. We've been talking about risk tolerances and what those thresholds look like, and what kind of ensembles should we be using, because we're saying, okay, we're not looking at a delta for risk change. We're not saying, okay, what is it now? What is it in the future? And what scenario are you basing that, lifespan end of risk on? And so we landed for right now on, yes, best available, because we know that's a moving target. And we want to see, we want to work with CCCS really and saying, okay, what kind of opportunities do we have to really help applicants get to an answer on this? And it's not really an answer, it's like a subjective answer, but where can we help best in that? And so I know right now there's some work going on with multiple scenarios and being able to present that. It's something that I've been thinking about as well, but it's something that when we review those projects, and we're just getting into the discussion on project review, how that analysis is going to look at and say, okay, how accurate is it versus how precise is it, and what scenario they use, thinking of that target and accuracy and precise, that common. So it's something that we know of, and we're going to, be as supportive as possible to applicants as they put that information forward and what they have available to them, knowing that we need to continue to align with all of the new work that's going to be happening in the future.
Yeah, great work, Eric. It's a challenging space.
Elise has been really important to our discussions on the evolution of the climate lens, and others around this table, which
I hit mute.
Oh, okay. Daniel, are you okay. I'm going to fill the space. I did want to add something, which is just that I think it's important over time that we continue to consult the learned and interested folks around kind of IBWG and these tables as we evolve into the new, the present, and continuing to rapidly evolve climate conditions. So this is very much a moving a target in which rapid learning and exchange of that learning is essential. So I think that's part of it. Alice, I see. Hey, great to see you. Alice, your hand's up. So over to you.
Thanks, Ted. Thanks very much for the presentation, Eric and Anna. Yeah, it's very exciting. Great work. I just had a question about wildfires, and a lot of it comes down to definitions of climate hazards and thresholds, and making sure we're all defining and aligning the same definitions. So for wildfires, I'm wondering if you're considering, like, what we started doing in our climate risk assessments is separating wildfire interface from wildfire air quality impact, and if you would consider doing that as well.
We haven't considered that at the moment, but I think that's a really great opportunity to explore. So I really appreciate it. It's for our direction, because we've also been trying to figure out, okay, where do we have good information on that future likelihood? Because really right now it's just seasonal. And it's like, okay, well, we can tell you what it's like over the summer until, but we can't tell you what it's like in 30 years. I used to work for the US Forest Service, so I'm very familiar with, like, a lot of it has to do with forest management practices. So how do we best help support that? So I think that's definitely an area we need to hone in on better. As I said, it's still draft and we're still working through, let's really define this. Let's define those aspects of what we mean by wildfire and what areas that we're looking at for, like, for example, the interface, and using what we have available to us through the wild and urban interface guidance. And also think about things like, air quality, which we're taking notes diligently. So I appreciate that comment, and we'll make sure that we include that information as well.
Great.
With that, I think I should conclude the discussion session, so we move on to our other presenters who kindly made time, and to all of you who are interested in hearing from all of our presentations today. So I would ask that Eric and Anna put your email addresses, please, into the chat, so that'll make it easier for folks to follow up with you and us. With this, I'm looking forward, Ron, to have Ron Mattiusi, a professional urban planner and former city manager, speak to us next in regard to wildfire. Perfect segue, Alice. Thank you. And Ron has extensive emergency management experience over the years as a director of the Central Okanagan Emergency Operations Center. And more recently, as a consultant, he's been asked to assist in the recovery efforts of Lytton, Grand Forks, and West Kelowna. So very pleased, Ron, to have you with us today, and over to you.
Yeah, thank you. I just want to acknowledge that I come to you today from the traditional and unceded lands of the Silk people of the Okanagan Valley, and I think it's interesting that we live in a fire ecosystem, and so fire is a natural part of our environment. I think they always knew that. Took us 100 years to figure it out, and to be able to, I think, over the last 20 years in particular, take measures to mitigate the impact of wildfire. So today I'm going to talk about 3 different fires that that I've been involved with in different ways, and they're all different, and in some ways they're all the same in the lessons that we've learned and unfortunately haven't learned, and some of my observations. Okay, so the first fire that I was involved was back in the Okanagan Mountain Park fire. 283 homes lost, about 10 were uninsured, and the fire was somewhat unusual. The Okanagan, in the last 20 years that I've been involved, we always get 1 or 2 fires a year. They tend to be more remote. They may have some evacuations. They rarely have loss of dwellings in the fires, but they are quite frequent. This one lasted a very long time, as you can see. Those are the different passes as the fire moved around because of the winds. And probably the worst day was the August 23rd, where it really destroyed most of those homes over a 2 or 3 day period. Most of them from embers. It was a rank 6 fire, and it moved very quickly, but it moved along the top of the mountains. So this is a mountain range. It moved along the top. So that was the first fire. 20 years later to the day, West Kelowna, we actually had an acknowledgement of the 2003 fire, and the next day we had the 2023 fire that we were dealing with in McDougall Creek. Interesting, very similar fire. Started at the top, 50, 60 kilometer-hour winds, pushed the fire very, very quickly. In this case, I wasn't involved in the emergency, having retired, but the speed at which this fire moved downhill was quite astounding. I had a very good view, unfortunately, from those pictures, and the movement of the fire into the community was at a very quick pace. The other thing that struck me in this particular fire was the fact that it was able to throw embers across a 2-kilometer lake. And so as we watched and started hearing reports that the fire was now in lake country and in Kelowna, it was, and so this is I can't remember the name of it right now, but satellite image of the embers coming across the lake at that point. So that was astounding. We'd seen embers fly considerable distances, but the fires on this side of the lake were actually as a result of the embers landing. And some interesting things happened, which we'll talk about. So this fire had a larger loss throughout this is the regional district, the city of West Kelowna, and the West Bank First Nation, city of Kelowna, and up here is Lake Country. So we had 5 jurisdictions. Probably the best thing is that most of the homes are insured. I'm now working on the recovery for the region and the city, and because most were insured, and because of some very good fire smart applications in some areas, the amount of loss is actually much less than it could be. I'll get into that in a second. So 20 years later, very, very, very similar fire, particularly in terms of scale. Third one was different in that it was the village of Lytton, and you're probably all familiar with it, mostly because it's constantly in the news, mostly because it hasn't rebuilt. And there's lots of reasons for that. Lytton was a little different. It was about 125 homes, 70% weren't insured. One of the things that the Lytton fire, and really was, they reached, as some of you may or may not know, reached the Canadian high of 51 degrees. But Lytton Valley, because this is the confluence of the Fraser and Thompson rivers, is always has very, very high winds. So when you get that extreme heat mixed with the very high winds, it's like a blowtorch. It moved through the community very, very quickly. It started down here at an ignition point at the bottom of a hill along a rail line, and then moved through the village within hours. In the report on this particular fire, it said it wasn't a canopy fire like most in BC, but it was grass. It was grass, catching the fences on fire, catching the wooden decks, the rooftops, and it moved very, very quickly. So a review of this fire said it would be unrealistic to expect, wildfire suppression response. Really wouldn't have made much difference. The numbers of trucks and firefighters they would have needed in that instance, first off, in the Fraser Valley, they wouldn't have them if they wanted to, but they really wouldn't be able. So it was very much like the Maui fire. High winds, hot, grass, and burned through mostly old housing stock. There's very, very little in the community that was new. And so looking at the fire, the suggestion was we really have to look at some resilience in the way we build back the community. And so that was part of the work that we were trying to do. Making the job even more difficult because, of course, we had the atmospheric river, which washed out all the bridges to Lytton, which means we couldn't move debris. Couldn't move very much in the province of BC. BC is a beautiful province. I don't know if other BC people are on the line, but it keeps trying to kill us. It's a great place to live. The other problem is, in this particular case, is that the village of Lytton had no municipal records left. And so it's really hard to rebuild infrastructure if you have no idea where it is or what it was. So we had no records, no bylaws, no minutes, no financial records, no building or engineered drawings. So the rebuild of this particular community was difficult. And, one of the reasons I bring that up is across Canada, we have a lot of municipalities of this size, villages and hamlets. And when things happen in these communities, they're much, much, much more difficult to rebuild or to recover than larger cities with infrastructure and staff and all those things in place. So observation number one, and the great work that many of you people in the room do and that we're hearing about, is we have the technical knowledge to build more resilient communities. What I've observed is we're lacking the political will, particularly at the building level. I saw it in 2003. The fire barely was still burning, and I think somebody had mentioned publicly that we may have to look at not having cedar-shaped roofs, which of course in the Okanagan may make some sense on the wet coast, but in the Okanagan, and we're semi-arid. I literally, it was within hours, I had a representative from the Cedar Roof lobby demanding to meet with me and saying that cedar roofs are as effective as any roof if you treat them properly and install them correctly and all those things. So I saw it firsthand back in 2023, some of the pressure that our elected people are under, particularly at the provincial level. The federal government did step in and said that they were going to provide money for the rebuild of Lytton to help them create a fire resilient community. And through the work of Dan and his team, we actually created a bylaw that would, a building bylaw that would in fact create fire-resistant homes and yards that, based on the work of the National Research Council. So, I mean, all of that was there. And the feds also threw in money that they could, for 1,100 square foot home, they could receive a grant of approximately $84,000 to rebuild to that standard. So they took away the biggest concern that this is a very, this community doesn't have a lot of money. Most of these people don't have insurance. Unfortunately, I'm not sure people could rebuild even with that much of a grant, because where would they find the other $300,000-$400,000 to build? And so I'm not sure that's going to happen with the people who actually lost their homes. It might happen with people who move in later. Council considered that, put in place the fire resilient bylaw, and then rescinded it. The new council rescinded it. And they basically suggested that they encourage everyone to rebuild at the highest fire standard and energy efficient standards, but they were encouraging. And the bylaw was rescinded. And I point out the date, it was rescinded after the announcement of federal money. So the decision was made not to impose these requirements on the people of Lytton. So just some observations, having sort of dealt with wildfires over the last 20 years, that the Fire Smart program works at the landscape, at the neighborhood level. These are photos. This is Wilden, and after the fire in 2003, this is the fire in 2003 on the right-hand side of the screen. This neighborhood, which was my neighborhood, they actually had the public lands use the Fire Smart principles. And although this was a rank 6 fire going across, the neighborhood didn't burn down. The fire responded as one would expect it would, ran along the ground, but it didn't actually, never went up into the crown. On your left, shortly after that, the developer owned thousands of acres in a neighborhood that he later developed called Wilden, immediately went in and started fire mitigation. And to this day, the neighborhood is maintained on a constant level. They still go in, it's a program. And although that fire crossed the lake, I think there was only one home. And if you saw the photos, you would have thought the whole neighborhood burned. And yet the fire didn't destroy, it only destroyed one home in the area. So once again, they have a very successful program. They started it years ago. They maintain it every year. They let people know on their website that they live in a community that has fire mitigation. This is part of their website, and explain to them that they have to shut down parts of the forest, that they're not logging for commercial purposes, they're logging to maintain forest health, and that they're clearing, and so the community embraces it. And now they've seen for themselves the impact of that work that we've done. So I think Wilden's just a great example of a developer in this case, embracing the principles and seeing that the land that he has and the trees are a definite asset for the whole thing, and really took steps 20 years ago to do it right. So lessons learned around recovery is that every year it becomes more difficult because every year there's additional layers of regulation. Lytton was subject to the cultural permitting process, which was never undertaken on this level before. So every single lot had to have an archaeological review, which of course added months to it. Not saying it's good or bad. Obviously, this was a First Nations village, and they had high cultural requirements, but it added to the time, and a lot of people in the community took exception. In fact, they had a protest a week ago, I think, over this issue that it was taking longer. The land also had to be cleaned up. There was because the whole village burned down, there were areas that had contamination, and unfortunately, the whole village had to be treated. So that really added to. So recovery is becoming more complex as we learn more about hazardous conditions that occur post fires. I think we should be moving from known risks, mitigating known risks, to possible futures. I don't think we've adapted. We haven't gone into that level yet. I think it's hard enough to get local governments just to spend the money to mitigate the known risks, let alone the potential of what could be. Recovery timelines on the recovery side are always overly optimistic. I was thinking the other day that maybe what we need to do is have some elected people work on a recovery. Two things that happen: they wouldn't come into town and promise to build it back better as quickly as possible, and secondly, they'd recognize that the impacts are pretty profound for a very long period of time, and so recovery is a very slow process, lots of heartache, and it takes an awful long time. So Maybe we should do a better job mitigating and spend less time recovering. Communities are extremely difficult to rebuild. The rural communities, they don't have the money. They have the older housing stock. And in BC today, we have 42 potential Littons out there if the thing happens all over again. It's also easier to rebuild the infrastructure than people's lives. I think we spend a lot of time on the technical side. We spend a lot of, engineers can rebuild infrastructure. It just takes money. And there are programs to do that. But rebuilding communities, very, very difficult. And I don't know how to do it. I just know it's hard, and I don't think we've had a lot of success really. And again, we must focus more on planning and mitigation so that we don't get in fact into the recovery business. So that's it. Thank you.
Thanks, Ron. Please feel free to put up your hand if you have questions. We only have a couple minutes here, so if you do have a question, please put up your hand or enter it into the chat. I see these. But while people are thinking, first of all, thanks, Ron. It's great to have your experience represented here. You've got quite a bit of experience in this area. One sort of surprising outcome, I mean, as you mentioned, we were involved at ICLR with the bylaw development and so on in Lytton, but this is a very high-risk community, potentially high motivation for protection because of limited insurance coverage for homes and so on. And I guess it would be good to get your sense of what could have been done differently to better facilitate fire protection for future scenarios. And you point out all the other small communities in BC and like across Canada as well that are in a similar scenario. What could we have done as private industry? What could the province have done? What could federal government do to better support these small communities in integrating fire smart practices?
I think that I think we've done a good job. I think on the fire smart, again, in this particular case, it was the housing stock and the grass as much as anything. But I think we've done it. I look across BC and I think we've finally reached a point where people understand that fire smart is important and they are developing programs. So I don't think that's the issue as much as, and I saw somebody from FCM here, I think we really have to spend more time with elected people to understand that, A, it can happen to you, and B, when it does, it'll be worse than you ever imagined. And so I think there's a general acceptance of the fire smart program, but when you get to the building level, I think there's a huge reluctance to implement. Dan, you were in some of those meetings. People saw the trying to not have the fire zone, ignition zones near their homes, and they would say things like, "I'm not having a concrete front yard. I want flowers. I mean, you're not going to let me plant my flowers." So it was really at that very personal home level that the resistance actually occurred.
Great, thanks, Ron. And there's more to explore in that area. We've got only a few minutes here, so we'll go to Lise for one quick question, and we'll have to move on.
Hi there. It's all about looking backwards, looking forwards. So when we calculate risk, it's based on what happened in the past. We're already talking about what we could have done in the past. And I think that if we look forward 10 or 20 or 30 years, we really need to think about transformation. And so one of the things about the resilience mindset is that it's a little bit about trying to get back what you lost, keep what you have. How do you see, Ron, people going through this kind of intense disruption and considering that they don't want to move back there anymore? Like, what drives people to actually really make that transformative change?
I don't believe the people in the village will make that transfer. I think people will leave, and they have left, and they will leave. And I think other communities have experienced that level of devastation. People did leave. I think the hope of the original mayor, where he agreed to some of those levels, some of those changes to put in the resiliency level, the energy savings, all of that was a view that new people would actually live here. And so his view, rightly or wrongly, maybe it could tell us, was that he was actually building the village for the next group of people that would live there. He didn't believe that the people in the village would ever accept that.
Great. Thanks again, Ron. Thanks for your question, Elise. Unfortunately, we do have to move on, although I'm sure we could discuss for some time. So we're going to move into the next part of our agenda, which is focused specifically on residential resilience. And we're going to start with Dr. Zara Jandagian, who is a research officer at the Construction Research Center at NRC and the lead of nature-based solutions projects under the CRBE initiative at NRC. Zara has a doctorate in building engineering from Concordia, and she's an adjunct professor at Toronto Metropolitan University. And her current research focuses on assessing the effects of nature-based solutions on mitigating urban heat islands and overheating impacts in Canadian cities. Dr. Please go ahead.
Thank you, Dan. Good afternoon, everyone, and thank you for having me. I'm going to talk about the guideline for overheating risk management in residential buildings. And I jumped to a very brief introduction. Can you see my slides?
Yep, we're good.
All right, great. So the climate heat waves have been identified as a serious concern to public health and well-being around the world. And the global statistics show that more than 0.5 million people died during the heat wave events during the past 2 decades. And unfortunately, the heat dome that hit the BC in 2021 resulted in 619 excess deaths. And the same event in Quebec in 2010 resulted in 280 heat-related deaths. And most of these issues and most of these heat-related mortality occurred in indoor environment. And when we look at the buildings, we see that none of the buildings are safe when the heat wave even hit the country, whether they are the free-running without air conditioning system buildings, or whether they are in the mixed mode buildings where we have the combination of natural ventilation and air conditioning system, or in the air conditioning buildings that we are hopeful that the HVAC system is working, but unfortunately during the power outrage or due to the heat wave events, we have a disruptive events and people cannot cool themselves to a certain degree. And that's the way that heat related death happens in indoor environments. And then we know that the exposure to heat will result in heat stress and thermal discomfort. And here in Ashbury 7, you can see that they define the thermal comfort scale that starts from heat stress, progresses from a minimum at thermal neutrality to full sweating, and then to failure of thermoregulation. Now, if sweating is established and if it is combined with a long exposure of human bodies to high temperature, let's say health effects will emerge. Now here in this table, if we assume that we have a young, healthy individual, the health effect emerge when the core temperature is higher than 38 degrees C and progresses from heat cramps or heat syncope to heat exhaustion and fatal heat stroke when the core temperature is more than 41 degrees C. And unfortunately, we witness the brain death when it is more than 44 degrees C. So let's say that all of these studies show that we need to address overheating so our core temperature body do not reach more than 38 degrees C, and it should be between the normal range of 36 to 38 to limit any potential health injuries. And so to look at these aspects, we, let's say, classified the factors that affect the heat-related health into 3 groups. The first group is related to people who are vulnerable to heat, like those who are older people, and because due to the age, they cannot, their body cannot regulate the temperature, so they have changes in their thermoregulation. Or children under 15 years old, that their thermosystem is not yet fully developed. And sick people, that they take some kind of medication, and due to those medication, they would impair the thermoregulation in their bodies. And unfortunately, people with low socio-economic status like poor and homeless, and Canadian people, because we are not adapted to this much of high temperature. And our houses, not all the houses, are equipped with air conditioning system. And so we do not have the adaptation opportunity to cool ourselves in those buildings. The other factor is the outdoor environment, which include the humidity, solar radiation, air pollution, urban heat island effects, and cold climate effects on the body. And the next is the indoor environment, which here include the spaces without air conditioning system, the spaces that lack the ventilation, and so we have inadequate temperature indoor, and it causes to more indoor air quality issues, and the indoor spaces that have a high internal heat gain. So the indoor temperature increased significantly during the heat wave events or even during the summertime period. When we come to evaluation of overheating risks, there are many approaches out there, but at NRC, we look at these approach. That first step is to set the time domain, whether it happens during the complete year or entire summer or only during the heat wave period. And we look at the overheating and evaluated it for fixed spaces and occupants. The fixed space in this case is the place that day-to-day heat wave cannot be carried over to another day, meaning that, for instance, you're in your office, you are very hot in your office, there's no air conditioning system, but as soon as you get home, you can cool yourself with your own air conditioning system. But in the occupants, this means that the people live in these buildings for 24 hours and they have no way to cool themselves. And so the effects of high temperature, this cumulative effect can carry away from day to day. And so based on these two approaches, we look at we actually considered the heat-related health and the comfort level. So we have two perspectives to look at, and in our work, we mostly focus on body dehydration, max core temperature, and max heat rate. And based on these two perspectives, we define the limit area that when we hit this limit area, we declare whether the heat wave and overheating happened indoor or not happened. And so we take the measurement to reduce the temperature indoors. So looking in general, the overheating effects, we know that are characterized by three attributes: duration, severity, and intensity. And these attributes are linked to the heat-related health indicators: body dehydration, rehydration rate, and max core temperature. And based on these two factors, attributes and health indicators, we define the limit criteria in our specific buildings: the duration exposure of the people who are inside, the severity of temperature and cumulative heat stress level, times exposure time, and intensity limit for these specific buildings that we look into it. And also we come up with some mitigation measures, and we could group them into three categories. The first is about the envelope. We look at the window glazing type, whether it is tint coating or clear one. We look at the solar shading devices, interior, wither pane, and external ones, and reflective surfaces to use the cool building envelope materials on building facade to reduce the surface temperature and air temperature. We also look at the space ventilation, meaning that the first strategy that we look is a natural ventilation. You open the window when indoor temperature is higher than the outdoor temperature, or only nighttime mechanical ventilation or personal fan ventilation to cool yourselves. For HVAC system, we look at two aspects. First is mechanical ventilation, which is heat recovery ventilator, or only mechanical cooling, like central AC, window AC, or the portable one. And we proposed these methods and applied them in three types of residential buildings located in Ottawa. One of them is row houses, or the other one is single detached houses, and the other one is multi-unit residential buildings, or MURBs. Now, here is the fun part. Here is our results. These figures show how building types are related to overheating risks. As you can see, the row houses present the lowest risk, followed by single houses and MURBs. Now here in this graph, the older buildings, which is presented in black bar, have lowest risk than the new buildings in green and net zero buildings in blue. And similarly, retrofit buildings in red have a lower risk toward temperature than the new buildings. We also look at the effects of shading devices, and we have simulated 5 shading types as mentioned here, like exterior one, interior one, electrochromic, and thermochromic. And the results show that in these exterior screen shading are the most effective one, followed by electrochromic and thermochromic glazing. And the peak daytime temperature can be reduced by up to 8 to 9 degrees C in single home and MERB houses. We also look at the mechanical ventilation in MERBs, and there are 2 ways for this mechanical ventilation. One of them is natural ventilation, as I explained, and the other one is nighttime ventilation. And you can see that by increasing the ventilation flow rate by 5 to 10 times the mean rate, the indoor temperature can be dropped by up to 6 degrees C at early morning in these MERB houses. We have also compared the effectiveness of natural ventilation by opening the window versus the nighttime mechanical ventilation using exhaust fan. And here, the natural ventilation is very effective, and it can reduce the daytime peak by 8 to 11 degrees C in single home and MERBs, and nighttime temperature by 9 to 10 degrees C in these units. We also take another step further and look at the effect of global warming on overheating risks. Here we show that in these figures, the effect of future climate changes scenario in terms of global warming of temperature increase, ranging from 0.5 degrees C, which is going to be in the near future, to 3.5 degrees C, which is going to be at the end of 20th century, which is the last bar. So here we also look at the different strategies, and our strategy shows that natural ventilation strategy can still be effective until the end of global warming, when the temperature rise at 0.5 degrees C, which is going to be in 2031. But for the future global warming scenarios, the mechanical cooling will be needed to cool our indoor spaces. And our key findings show that spectrally selective or tinted windows and exterior shading devices are the most effective one that can be used in our houses, but need to be combined with other measures like natural ventilation. And the reason for that is because natural ventilation shows that it has the most effective means to reduce and eliminate overheating in all of our buildings. And then we should also be able to use the high potential of nighttime ventilation with oversized exhaust and supply fan, and use heat recovery ventilation with summertime bypass option and powerful fans. And by the end of global warming, when the temperature reach to 1 degree C in 2040, the buildings will need mechanical cooling. And our results show that we need to have this mechanical cooling for all of our buildings in Canadian cities to be able to eliminate and reduce the effects of overheating. If you want to find out about our studies, please look into this report, which fully explain about what we have done so far. And thank you so much for your attention. If you have any question, you can pass it on my way. This is my email, and Dr. Aziz Labadi's email as well.
Thank you. Very, very interesting topic. And as we heard in the last IBWG meeting, a priority for the 2025 codes, and I think also for 2030 codes. So what you're presenting to us is very important for future building stock in Canada. Hopefully,
talk about, if you want me, I can also talk about how we send out the code change request so far for the next cycle of MDCC. If you have time, I just felt we don't have time, so
Right, we would like to hear about that. Unfortunately, we don't have time today, but we certainly would like to hear more about that. Hopefully, if we have a couple of minutes at the end of the meeting, we can turn back to you. Thank you very much. So very, very excellent presentation. Next, we're gonna pass it on to Stephanie Coleman. So Stephanie Coleman is the Sustainable and Resilient Housing Industry Lead with NRCan's LEAP program. Stephanie spent several years as a renovator, and then worked with Building Knowledge Canada for several years before joining a home builder, Doug Terry Homes, as Chief Sustainability Officer. Stephanie actively participated in the CHBA, including serving as National President in 2019 and 2020. She has completed her Master's in Environment Business from the University of Waterloo, and is started up for a PhD program. Also at Waterloo. So thank you very much, Steph. We'll turn it over to you.
Thank you very much. Let me see. Here we go. Okay. So yes, I come from the construction industry. I worked 18 years in construction, first as 15 years as a renovation contractor. And then my last job before joining Enercan 3 months ago, my first time in government, was with a builder. And as Dan said, I was president of the Canadian Home Builders Association, which is the national industry association. As I was completing my master's, which is a Master's of Environment and Business, it was looking at sustainability through a business lens. And what surprised me was that what I was learning in school about all of these, things like carbon and adaptation measures and all these different things, they weren't at the time anyways being discussed among builders, and especially smaller builders. And so this was quite a shock to me. And so what I did was I took my capstone project, which I completed this summer, and I did several types of academic research, including a focus group and survey with over 20 leading builders in Canada. And so I'm going to share a little bit of the capstone outcomes, as well as the feedback that I got from the construction industry. So I started by looking at ESG because I saw all these things, on the news and whatnot about how the finance industry was asking for climate-related information, and really nobody was talking about it in the industry. And so I wanted to research and understand what exactly they were looking for and what the issues were. And so then I also noticed that the Securities Exchange Commissions in the US and Canada also had put out proposed guidelines or regulations, actually, which I believe are still pending. And so I wanted to dig into this because it became very evident to me that this is something, and I was working in the industry a number of months ago, and this is when I was doing this, that was very evident to me that this was something that was going to impact the industry. And so what came out of that was some information that I learned about on a concern about unpriced climate risk and asset valuation and a misallocation of capital. And those were some of the key things that the finance industry was concerned about, particularly on the unpriced climate risk and asset valuation. Examples would be, you've got a house on the coast in Florida. And right now, the price of that house, the value may be very high, but over time, with climate risk, sea level rise, hurricane risk, that sort of thing, that property may no longer be insurable, and the value drops, which has not only an impact on the owner of that asset, but also on the municipality that absorbs the tax base from these type of assets. And so I also did some further investigation and saw that there were various reporting standards that the finance industry was asking for, including the Task Force on Climate-Related Financial Disclosures, and I began to dig into that. And since then, there's been a lot of activity in this space. The International Financial Reporting Standards has released some international standards on ESG reporting, which was very much what the finance industry was calling for. And so I wanted to understand what were these material issues that the home building industry needed to be aware of. And so two things that came up, one on the mitigation side, which is the carbon reduction, energy reduction piece, was identifying what the carbon emissions were for the businesses. And then on the adaptation side, which is what I use the term for, understanding climate risk and the strategies to mitigate against climate risk or adapt against climate risk. Those were the things that the finance industry was asking for, what is the business's climate risk and what is their strategy to deal with that risk for physical and transitional risks against climate change. And then simultaneous to all of this, and these are from June, May and June, I was seeing Florida was all of a sudden going into, or perhaps not all of a sudden, but it was in the news all of a sudden, they were experiencing insurance crises. California had a big announcement of insurance withdrawals for various reasons, but nonetheless, these are impacts that directly impact asset owners and homeowners. And Louisiana had been in a insurance crisis for many years, and I actually not that long ago was talking with a builder in Louisiana on this very topic. And so, of course, it's no surprise that we know that the insurable losses have been escalating quickly. So then I began to think about, well, hold on a minute. What is the lowest common denominator, if you will, in the home buying system? You've got the home buyer wants to buy a house, whether it's new or existing. They give money and then they get a house in return. However, most people do not have the money to buy that house, and so they have to get lending, but the lender requires insurance. And so if anything, like what we were seeing in those coastal states happens, then it can destabilize the entire, not only that single purchase, but the entire home buying system. And so then that's where I began to explore on the insurance side. Also, of course, in the news, I was seeing a lot of how, we have a housing affordability challenge in large part due to a housing shortage problem. And so there's what I call the housing rush, like the gold rush. And so we've got this big push to build more homes, but at the same time, we've got this increasing climate risk. And so what I did was I sort of compounded all these together onto a very simple graph that was inspired by some work that Chris Chopik had done. And on the vertical axis, you see the climate change impacts, so an escalation of climate impacts. And on the bottom is our construction practices. And so if we assume that our construction practices stay the same while we build more homes, logic has it that our risk goes up. And so looking to find out what these mitigation and adaptation measures are that we need to employ while maintaining housing affordability is sort of the sweet spot, or it's where we want to get to reduce the climate risk in the home building industry. So when I surveyed and also did the focus group with the over 20 leading builders in Canada, one from the US, and then I also looked at data from the public feedback to the Securities Exchange Commission and the Canadian Securities Administrators from leading insurers, financial industries, construction, et cetera, who provided public feedback on those ESG proposed regulations. I came up with some gaps and barriers that were pretty consistent across the board. And so one was sector-specific standardized guidance and methodologies. And so this relates to both mitigation and adaptation measures, but there seems to be a hodgepodge, if you will, of various things that are happening. And when you consider the various challenges that the building industry has, having this kind of messy situation that they have to navigate can become completely onerous to them and debilitating. And so having sector-specific standards that are very clear guidance methodologies is a gap and would be beneficial. Another thing is having reliable climate data as well as mapping and modeling. How do we know what the risks are if we don't have the tools to tell us what those risks are? And so there are maps and whatnot, but is it done in a way that is palatable or able to be absorbed by boots on the ground type of companies, of which, by the way, 70% of builders are actually small builders with small staff, small resources. The other thing that was a gap that came up was signaling from the building codes, finance, and insurance. And so again, when we're talking big companies, they are hearing things from insurance, they are hearing things from finance. However, these run-of-the-mill builders that you see in your everyday communities are not getting information from these entities. Homeowners assume that building codes have all the safety measures that are required, and only 10% of the builders that I surveyed had indicated that they were aware of any business or person not being able to get insurance related to climate risks. And so, they identified their number one priority as, no surprise, labor shortage, right? And didn't necessarily even consider climate change as being a major concern, not one of the top, 2 or 3 concerns. And so that's because they're not getting the signaling, the boots on the ground at this point in time. Some of the barriers from the business perspective that the builders had indicated was, again, this comes back to the lack of resources, tools, and guides. that were clear and easy for them to be able to use and employ. Their own internal systems and processes are just not set up to capture the data and the data that is needed in order to do different analyses and to identify the risks. Of course, they have staffing shortages not only in the trades but also in the office, as well as pretty significant knowledge gaps. And then when it comes to housing, there's so many different pressures that come from all different levels that come with a price tag, that it's not necessarily the price of a single measure that's the issue, but it's the compounding impact that impacts the affordability for homeowners. So that was the work that I had done prior to joining Natural Resources Canada, and since joining in July, I've put together the framework for a workshop. So the LEAD team actively engages with the building industry, and we meet with them on a regular basis. We build workshops, resources, and tools with the goal to build capacity in the industry to be able to address those gaps, like the resource and knowledge gaps that the industry has identified, to encourage them and to help them to be able to meet the advancing issues of the day, including the building code. And so we already have a lot of work underway on the mitigation side when it comes to energy reduction, carbon reduction, and a number of different tools and workshops. And so now we're looking to twin that up while we're already in the room with the builders, layer on the adaptation piece, look at climate mapping and utilizing the tools from the many people like on calls like this and the hard work that you're doing to be able to help to disseminate that out to the industry while we're already with them. Looking at what are the hazards, what are the maps saying, what are the resilience measures, what are the cost benefit for these, how you can communicate this to homeowners, which is of course another big challenge. And so so that is the direction that we're going with on this measure, and I will stop there.
Thank you, Stephanie. That was excellent. And if we could ask Stephanie and Zara to stick around for 5 or 10 minutes, if you're available, because we're actually at time for the meeting, but this meeting is being recorded, and we'll share the link with the group and people will be able to see the discussion. If you're able to stick around, that would be fantastic. But I'm going to quickly pass it over to Chad before people leave.
Well, thank you very much to everybody. Thank you to the presenters, Eric Thurston, Anna Murphy, Ron Mathieusi, Sarah Jandagian, and Stephanie Coleman for their wonderful presentations today. Thank you to you as IBWG members or maybe first-time visitors. Hope that you'll consider joining us again. In that vein, there's a directory. A link will be shared again in the chat. And we would invite you to add your name to the IBWG directory to further assist us in new ways that we can facilitate connections. It will be a publicly accessible database of leading infrastructure, buildings, construction, and other built environment professionals working across our sectors. My surprise announcement was that the State of Play report, which will be released in mid-November, we are finalizing a translation of a very substantial report, an update on our 2017, which you can find at ibwgsop.org. But we have a new version. Thank you to the work of Christine Zimmer, Peter Nimrichter, and many of you who contributed to making sure that that's a rich report. So we're getting the French and English versions. That's what I think I wanted to add. Dan, is there anything else at this point? December?
December 13th, right?
13th will be our, and we welcome you to reach out to us and connect us how we can make this useful. And for those of us who can stay on for a moment to hear a little bit more from Zara or Stephanie, welcome to do so. And also know that we'll have the recording here available for those who missed the end. Maybe we turn back to Zara if we want to kind of echo the order. I don't know. How would you handle that? Either anybody?
Right. Maybe actually a question. If anybody has a question for Steph, and maybe we'll give Zara a couple of minutes to talk about the code changes that she's been working on and the process that she's been going through. I think that would be very interesting to hear the next steps on your work. So if you do have a question for Stephanie, please put up your hand. While we're waiting for questions, so I've been talking with Stephanie for some time about this topic, and Stephanie's got a really great perspective, having come from the home building industry, having served as president of CHBA, and her insights are valuable for moving the topic of resilience through the building industry. And Stephanie, you pointed out a number of gaps and barriers to resilience in the industry. And I'm wondering if you could pinpoint 2 to 3 key areas that should be developed like very quickly to move us forward and to prepare the industry for resilience. It would be nice to hear.
Sure. So some of the things that immediately come to mind, and this was what I was going to try to do with the workshop if it wasn't able to be pulled together, is number one, understanding what the risks are in the area and in communicating that to the builders, but not just the builders, also to the municipalities, because as Dan, you and I have talked about, we know that there can be gaps even within the current systems where we can end up with risks for flooding, like storm sewer flooding and that sort of thing, just in the current processes. So number one is understanding what the risks are in those specific regions, and then marrying that with measures that are achievable and attainable for the industry, so that they can then do something with that. And so, but the other thing too that I know I've said many times, it takes a while for building codes to advance. And so it seems to me it's a hard sell for builders if builders or homeowners are not getting signaling from insurance that there's a risk, that their house may be at risk of not being able to get insurance, for example. It's hard for a builder to be able to sell an upgrade, which is what it's perceived as. And I know that because for like 18 years, I was trying to do that for energy. And so now it's like doing the same thing for resilience. And so Dan knows I love this sort of concept, not that it's perfect, but if there is some sort of a mechanism like a labeling program that's voluntary, that offers some sort of you do these extra measures, you get some sort of benefit, like you can access insurance where you couldn't before, or maybe there's a little bit of a discount on your insurance or something like that. It at least can sort of bridge the gap between where we are today and where the codes will get to over time, just because that process takes a long time. And so having something that the builders can sell, because otherwise having done it on the energy piece, it is a tough slog for sure. So that would be some of the pieces. Those are about 3 that I would say are helpful.
Great, thank you, Steph. And that certainly resonates with what we're hearing from not only the building industry, but interestingly, the insurance industry, which is often in the same position as the building industry during post-disaster rebuild processes, where they're looking to minimize costs and reduce technical complexity. So thank you, Steph, and I'm sure folks can reach out if they have more questions for you. And about the LEAP initiative, that's a very important, very highly regarded program in the building industry that's been going on for years and years on energy efficiency training and other topics.
Thank you. I put my email in the chat. I do have to hop off now, but unless somebody has a quick question, but I did put my email in the chat, and you can feel free to share that if anybody's looking to reach out to me.
Great. Thank you again, Stephanie.
Okay. Thank you. Bye, everybody.
So Zara, if you do have a few minutes, it would be good to hear if you had a few extra slides on the code change request process. It would be good to hear what you're working on.
Well, I can share those, or I can just talk about it because I know everybody is leaving the meeting room. So I can say right now we are working at long-term care home facilities, social housing, and primary schools. And we selected several buildings in Montreal, Toronto, and Vancouver. And we are working and simulating the passive mitigation strategies that I just proposed. And we look to see which one of these buildings better respond to one of these strategies, and how we can actually mitigate and eliminate the effects of overheatings for indoor temperature in these specific buildings. And we look at the thermal comfort model for older people and younger generation. We developed that model. And with all of these supporting documents, we reach out to a standing committee on on housing and small buildings and usage and ingress. And we had several discussion and meeting with NBCC for the next cycle. We talked that we already have the lower temperature threshold in the NBCC that during the winter time, the temperature shouldn't be less than 18 degrees C, versus we do not have any temperature for when we have the summer period. And there is nothing mentioned in building code. And so we had several discussions. We sent out the code change request, which is still under review. And during this discussion, one topic that emerged was that, what about the relative humidity? Are you also looking at the effects of humidity for indoor temperature and that on human health and thermal comfort? And so we are looking at that aspects too. But so this is how we are proceeding right now.
Great, thank you, Zara. And I guess your sense of the status of the process and the likelihood that what you're proposing would be represented in the 2025 code is the feedback to date from the Housing and Small Building Committee, that they're very receptive to the changes and that they can be incorporated?
The housing and small buildings were very receptive to the changes that we proposed, versus when we had a meeting with usage and ingress, and when we had a meeting with the committee of NBCC and the CSA to talk about this, to add at the national level and national level in the building code. They mentioned that without relative humidity percentage or some range, we cannot go for this proposed number, because based on what we find out, when the indoor temperature is more than 26 degrees C, it induces some adverse effects on human health and comfort, and it will also affect the not only human health but also quality of sleep, and so it will affect the mental health the other day and the day after that. So our modeling showed that this is very important to consider, but right now we are still under communication and we are still having the conversation with them.
Great, thank you. Thank you, very interesting. We'll look forward to following the process over the coming months.
Sure, I would love to talk about it. So
on the topic of codes, in the chat, I just threw a link to the public consultation that's underway. Maybe we can share that in our notes that Anna will help us with to ensure it follows our last meeting. Well, this is helpful. Anything else, Dan? I think that we've covered a lot, and a few people have stayed on to hear a bit more, but I think at this point we can probably conclude things.
Great, thanks. Yeah, there's still a few people online. Thanks for sticking around. I suppose to note for the resilience and code change request work, this group could potentially support these changes by conducting the review that you've noted there, Chad, and submitting letters of support or supporting statements. So that's an important part of the process.
Okay, we can work to capture that in our notes.
Okay, great. Well,
thank
you.
you.
Thanks for sticking around.
Thank you for having me, everyone. Have a good day. Take care. Bye.
Bye. Have a good day, everybody. Okay,
bye.